All right, we're going to talk about limits involving infinity and kind of asymptotes of graph. We've dealt with asymptotes of graphs before, so this is going to be a refresher. So when we're talking about limits as x approaches infinity, what we're really looking at is the limit as x goes to infinity of f of x equals L. If for every epsilon greater than 0, there exists an m such that x is greater than m goes to f of x minus the limit, the absolute value of that is less than epsilon. Okay? And then the limit as of f of x as x goes to negative infinity equals L if for every epsilon greater than 0 there exists an n such that x is less than n goes towards the absolute value of f of x minus L is less than epsilon. So what we're really looking at is this idea of what happens when we go to infinity or negative infinity. So if you remember back, that's kind of like that end behavior. Where are we going towards? Where are we approaching at that end behavior? So in this example here, our end behavior is as x gets really, really big, what we're doing is we're approaching the value of 0. So this is my limit as x goes to 1 equals 0. So if you remember back in pre-cal, what we did is we found the horizontal asymptote. That was our end behavior. Well, this is that same idea, except now we're looking at it based in limits. Okay, so here we have an example of the limit as x goes to infinity of 5x squared plus 8x minus 3 over 3x squared plus 2. Well, what we're really doing is we're going to look at dividing everything in the top by x squared and everything in the bottom by x squared. So that way we have the limit as x goes to infinity of 5 plus 8 over x minus 3 over x squared all over 3 plus 2 over x squared. And the reason we're doing that is because I know that the limit of 1 over x approaches 0. And 1 over x squared would also approach 0 and so forth. And so what we get here is we get 5 plus 0 minus 0 over 5 or 3 plus 0, which is 5/3. So if you remember back in pre-cal, what we did is we said, oh, what we're going to do is we're going to look at our lead terms. 5x cubed over 5x squared over 3x squared. Well, that reduces to 5/3. It's the exact same idea and concept. Okay? So now we're going to look at this next one. And a lot of times when I ask students to look at end behavior, I kind of want them to kind of generalize and kind of get this idea of what happens if I plug in a positive infinity. What are my signs going to be? What's going to happen there? So here we have a problem in which we have the absolute value in here. And so we have x cubed minus 2 over the absolute value of x cubed plus 1. And so what we're looking at here is what happens as we are approaching infinity here, okay? And so let's look at the first one. So what I'm doing is I'm looking at, as I'm going to infinity, what happens to this absolute value? Well, I don't have to change it at all. Remember what the absolute value does is it takes a positive number, it's a distance from 0, so it takes a positive number and it keeps it as a positive number. It takes a negative number and it negates it, okay? And so now we have this whole thing of if I have a positive number, I just drop the absolute value. If I have a negative number, I'm going to negate this, okay? And so now what we're going to do is we're going to look at, okay, what happens if I plug in infinity? And so we're going to use the same approach we did up here, okay? So we have 1 minus 2 over x cubed. 1 plus 1 over x cubed, and this is the limit as x goes to infinity, right? Well, we know that these two back pieces here, 2 over x cubed and 1 over x cubed, those are going to be 0. And so I end up with 1 over 1, which is 1, okay? So when I go to positive infinity, I'm going to have a positive 1, which kind of makes sense because if I put a positive number over a positive number, it's 1. So now in the second one, we're going to do the same thing, but now we're going to negative infinity. And so now I have 1 minus 2 over x cubed, and I have negative 1 plus 1 over x cubed. Okay? And so now I end up with a negative 1. So as I go to negative infinity, I end up with a negative 1 quantity there. Okay? And so we kind of have this idea, which actually kind of makes sense, right? If I were to put a negative number in here, I get a negative number, right? Negative number cubed. And if I put a negative number in the absolute value, it becomes positive. So it becomes positive number cubed, which is what we're looking at here. A negative negative turns into a positive, positive cubed. Okay, so that same idea. So I don't know if you remember the oblique asymptotes. What we're going to do is the oblique asymptotes happen when I have a degree 1 higher than my denominator. And so what's going to happen is these oblique asymptotes are going to be that kind of diagonal lines there. We still have a vertical asymptote. I would still have a vertical asymptote here at 2, but now instead of having a horizontal one, I actually have a diagonal. And the way I'm going to find that diagonal is I'm going to divide these out, okay? So I'm going to do long division and divide these out. So 2x times what is going to give me x squared? Well, that's going to be 1/2 x. So that's going to give me x squared minus 2x. And remember, I'm subtracting that, okay? So when I'm subtracting that, now my x squareds cancel out. I get 0 minus 2x, which is 2x minus 3. I now look at, well, 2x times what gives me 2x? Well, that's a positive 1, so that gives me 2x minus 4. And then my remainder here is going to be a positive 1. I don't really care about the remainder because what we're looking at is this idea of really large numbers. Well, 1's not that big of a number. So my oblique asymptote now is 1/2 x plus 1. Okay? So if I were to write this in here, this would be, with my remainder, would have 1/2 x plus 1 plus 1 over 2x minus 4. So if you remember doing that. Okay. All right. So now we're going to find the right hand and left hand limits of this and kind of look at if we're going to a positive or negative infinity. So let me erase this to give myself a little bit more room. So here I have the limit of x as it's approaching 1 plus, the right-hand limit of 1 over x minus 1. Okay? So if you remember, so we said that 1 over x, as x goes towards that, is going to be 0. That's fine. But here we're going to 1 plus. And so we're really looking at what's going to happen to this value here as we're going to values that are slightly bigger than 1. Okay, so we know that if we plug 1 in here, we have a problem, right? We have 1 over 0, which tells us we're going towards infinity, but are we going towards a positive infinity or are we going towards a negative infinity? And so we want to kind of get this idea of utilizing kind of a concept here of positive numbers versus a negative side. And so if I look here, I'm just going to kind of plug in a value here just to kind of give you an example. So let's say I plugged in 1.1. 1.1 minus 1 over 1. Well, that equals, this is 1 over a tenth, 1 over a tenth, which gives us 10, right? And if I plug in 1.01, it would give me 100. 1.001 gives me 1,000, and so on and so forth. So now it's showing me that this is going to what? It's going to positive infinity. So this is actually going to positive infinity because I'm taking a value here. I'm taking a positive number, and I'm dividing it by a positive number. So positive divided by a positive is going to be a positive, okay? So that's kind of that conceptual idea of what we're looking at. We should see that as this number gets smaller and smaller down here, the whole expression is going to get larger and larger and larger. Okay, but are we going to a positive or negative? Which makes sense when we look at this graph. So at 1, it goes like this, right? Okay, there's our graph. So as we're coming back along here, we're going up to infinity. Now in this one, it says, oh, I have values that are slightly less than 1. And so what's going to happen in my denominator? My denominator is now going to be negative, so I have a positive number divided by a negative number, which is going to give me a negative number. And as this gets smaller and smaller, so I have 1 divided by a smaller and smaller number, it's going to force that to be negative infinity. Okay, so I hope that kind of, you guys kind of understand that. We have kind of talked about that, what's happening to the graph as we're getting close to that item. We did not use the limits though, but that's the idea. So we're going to find the vertical and horizontal asymptotes. So if you remember, our vertical asymptotes are where this equals 0. So I'm going to factor this, negative 8 over x minus 2, x plus 2. So I have here, my vertical asymptotes are going to equal plus or minus 2. My horizontal asymptote is now what happens as x goes towards infinity and negative infinity. They go to the same spot. So if I take 8 or negative 8 and I divide it by a really large number, where is that going towards? Well, remember what we said is any number over x or any number over x squared is going to 0. So my horizontal asymptote is 0. Or the limit of f of x as x goes to infinity is going to equal 0. Okay? So that kind of tells me there. We could really talk about end behavior. We did talk about like what happens when it approaches infinity. We could talk about what happens as it approaches from each side here. Where's it going to go? That's all kind of the idea of limits involving infinity.